Jefferson County Public Health and work with CPOW on the soils class training. And what we want to do here is take a look at a soil pit to see how we would evaluate these soils, the subsurface, and see if we can make use of these soils, see if these soils are suitable to accomplish two things: treatment of the wastewater and dispersal into the environment. If they can't do both of those things, they're not suitable. Some soils can provide dispersal, but not treatment. Some soils could provide us treatment, but aren't very good at dispersal. So when I think of a soil that could provide dispersal, I'm thinking about something really porous and lots of open structure, and yeah, the water's going to flow through there. We're never going to see it, but the water table may see it, and then your well may see it, and then you'll be drinking it. So that's why treatment's important. Other soils that might provide treatment, clay soil, tight soil, but it's going to be really slow at the dispersal. So if we load it too fast, then we're going to have surfacing effluent. You want that in your backyard? Probably not. So we're going to do this site evaluation and then an evaluation of the soils. And actually our analysis starts even before we get to the field. First thing we do is we get an address for the site that we're going to be working on. Not every site has an address. Then we're going to do a little bit of research. We're going to go to the U.S. Soil Classification website, NRCS, and we're going to look at what they know about these soils here. Arm us with a little bit of information ahead of time. And that's one of the things that a competent technician needs to know. The preliminary investigation even before you get to the site. The other thing you can do is you can look at some geological information. Now, all this information is available to you, and there is a learning curve. First time you go there, you're going to be cussing and mad at me. Second time, you'll still be mad at me. Third time, maybe not so mad at me anymore. And then pretty soon you're going to be comfortable with that information, and it's going to really arm you when you go to the field to help you evaluate the site. So let's say we've done that homework. Now, Warren did send me this location, and I admit I didn't go to do my homework first. So I didn't follow rule number 1, do your homework. Take a look at the site before you get there. But actually, even looking at the topographic map helped me. And it was a Google map, aerial photography. Does that tell you a lot right off the bat? Right away, I knew I was on flat ground near a creek. Okay, that's a lot of information already. If I see flat ground, creek, I don't remember if I saw the lake there, but guess what I'm going to start knowing already? Water table conditions. Better be watching out for that. Okay? So I had that information. The other thing that it tells me near a creek is, what's the environmental conditions or the depositional conditions for these soils? I'm betting it's going to be alluvial, water-carried, sedimentary material. Okay? So I already know a lot just looking at a Google map. So that's the homework you got to do ahead of time. Now, I'm here. I'm also going to advocate for the use of these soil logs. The more and more you do of them, the less and less you'll need these, but and the faster you'll get at it, but they key you in on the important things that you need to do even before you get to the site, even before you dig the hole. So right now, I'm going to walk through this. So the first thing it asks me is about the soil parent material, and it says circle all that apply. Now I'm going to run through our choices and I'll talk about it. Till, outwash, lacustrinal, alluvial, loess, organic matter, bedrock. Okay? Till and outwash are related to glacial deposits. Okay? And you may not have a glacier there anymore. The glacier could have gone and receded. But those are the depositional environments and the forces that are carrying those sediments there. Lacustrinal means lake. Lake bed, flat areas. So if you're out on the Pierre Shale or you're out in the Mancos Shale, what kind of environment are you thinking those were deposited? Marine or lake bed? Okay? Fine grain, clay, silt, sand. But you can also get flatter areas where there isn't so much topography. Now if you've got a flat area and the stream has not much energy, is it going to be able to carry rocks like this? these things tell you there's a lot of energy in the deposits of these materials. So that's the other thing that can help you, whether you're going to find a lot of rocks, coarse grained material or not. So that's alluvial. But you can have flat areas where all you're going to do is have occasional flooding. You're going to find clay, silt, sand, fine grained material, because that's all the stream or that the depositional environment has the energy to carry. Now the next one here is loess. That's wind blown. Now I know we get a hell of a lot of high winds up here. Now Boulder, they could probably carry some things this big. But actually, I know some places where it's windy, when you get 70 or 80 mile gust, you ever been sandblasted? And you know, and you see what happens to your windshields when those get hit. So it can actually carry some pretty coarse material. But typically, winds are going to carry finer grains material, the fine sand, silt, and clay. So those would be those kind of deposits. So there you go. Organic, again, we're going to be near a lake bed or a boggy area, a lot of cattail. We're going to see plants and vegetation that's going to give us indication of the organic material. And then bedrock. Don't see bedrock here. How about up the slopes there? You don't have to go too far, and you're into out here. It's metamorphic and igneous bedrock, hard stuff. All right, so good. Those are some of the things we look at right away. So right away, I'm going to say, I did my homework. I'm going to say this is an alluvial deposit here. That's what I'm probably going to look at there. Landscape position. Look around and see what the lay of the land is. The way we describe it is going down from a mountaintop all the way down. So the terms that we have are summit, back, side slope, foot slope, toe slope, and then we'll put in the slope shape. That's why these things are, sheets are really good. They give you the slope shapes here. They give you all the definitions and terminologies that you need. So there's a toe slope. Are we at the summit? No, we're not at the summit. Are we on the side of a steep hill? No, we're not there either. Are we at the foot? And actually, as you look at this diagram here, you'll see that we're in the toe slope area, right? Good. Okay, and then what's the slope here? Is this about 50 degrees? Give me a number.
3.
What's the slope here?
1 to 2.
1 to 2, 3. Going once, going twice.
2.5.
All right, 2.5. How about if I just kind of say, overall, I'm going to call it flat.
Flat.
Okay, pretty flat. Good. All right. So now we've done that documentation. Vegetation. Some of the other information you put here: vegetation, weather conditions, soil survey map units. You know, again, that's if you do your homework ahead of time, you'd already have that filled out. And our location and observation. Pit 1. Well, that's the only pit we got here. Pit 1. And our elevation, 8,000. Let me see. I gotta check the pressure in my ears. 8,312 and a half. Is that right? No, I don't know what it is. What is it? About 8,000? 9,000? 8,500. Yeah, my ears are a little off. 8,500. Okay, good.
Probably about 3-4 minutes.
Till I'm done?
And then we go into questions. You continue over that.
Yeah, 3-4 Roy minutes. That's 30.
Roy minutes,
That's
yeah.
30 or 40.
Just getting warmed up, guys.
Great. So we've got all that. That stuff is really important ahead of time. It's going to help you with your design. Now you get to the easy part, the pit, okay? So I've got this beautiful soil tape. I ordered it from Soil Tools online. It's really nice because when you take photo documentation, you can really show your layers there and the distances, so that when you have to argue with your regulator, you can say, look, the picture doesn't lie. Here's what I saw out there. So as we look at this pit, what do we see here? We do see a lot of rock, right? So we might be concerned about that. Hey, are we going to make those rock cutoffs, which is 35% if you're on a type 1 soil. Remember what a type 1 soil is? Sand and loamy sand, right? Mostly sand, so either it won't form a ball or it'll form a ball and maybe I can throw it up in the air and it'll stay together, maybe it won't, but I can't make a ribbon out of it. So that's going to be sand. Then I move into loam, which is kind of an even mixture of sand, silt, and clay. Then I move into a clay loam, which has increasing clay content. And then the final type 4 is going to be a clay soil. So now we're going to go ahead and log this here and see our different horizons. And we're not going to go into a whole lot of detail here. Is this perfectly level over here? There we go, perfectly level. All right, so that'll help us measure and see these different horizons. So we can see this first layer comes down here about 18 inches, and then we come down here to 44 inches. And what happened there? My tape is wet at 44 inches. What the hell's going on? Did it rain last night and fill up this hole? What do you think that is? You think that's a water table? Probably a water table. And then there's another weird thing going on here. What else do you see that's weird? Anybody see anything weird here? Organics. What the hell are these things?
Texturing,
Roots.
piles.
Why are all these roots stopping right about here? I got a few going down. Why do you think they're all stopping about here?
Seasonally high water table.
Maybe an indication of a higher water table.
That's like the maximum water table, otherwise they would rot. Under the water.
Probably that's what we got. So again, another cool indication that's saying, hey, you know what? Even though the water, I've got another 2 feet right this time of year, maybe in springtime I don't have that. I got to design for the worst case conditions. So we'd have to say,
29 inches.
this is about all I've got a usable material here. Now typically, when you think about most designs, what do we like? At grade, okay? So that means we got to go down 2 feet and then we start using it. In this case, you go down 2 feet, you're going to be in the water table. Okay, so that's why I think a lot of times you should start thinking about getting over a fear of mounds and start thinking about not full mounds maybe, but partial mounds. Wherever that limiting layer is, make use of this stuff. The best soil treatment material is right here when you got the organics in it. Now, we don't have the luxury of deep soils all over Colorado. We want to make do with what we got. So some of these materials are pretty good. So we might have to say, hey, this is my limiting layer. I got to go from here up. I can make use of this, then I got to bring in some sand, and then I'm going to do the rest of my system. But let's say I didn't have a water table condition here. The next question is, can I use the rest of this? Now, for the sake of argument, I'm going to say this material is more or less the same from here down to here, okay? Okay? I don't know that I necessarily see parent material, but I do know that the amount of organic material is decreasing with depth. So I'm probably getting closer and closer to what is the parent material of the soil. But I know I don't have bedrock here, so I don't have to worry about bedrock. So now I would start using this chart to look at my layers, and I'm just going to have to cut this short. So I'm going to say from 0 to 48, it's more or less uniform in this case. Now, you could argue with me and say, no, I want to log it a little bit better. I want to say from 0 to 6 inches is topsoil, and I'm going to texture that, and I'm going to say, great, but why? You're not going to use it. In this case, we are because of the water table, so I would agree with you to do that. Then I'm going to go from 6 all the way down to the water table, and then I'm going to say at 44 inches, I've got groundwater, but I also got groundwater, and actually I should back up. I'm going to go from 6 to 24, because I think I've got indications of a high water table at 24 inches. Then I'll log it for the rest of it because this is just for the sake of this class. Let's say I could actually, I didn't have this water table condition, but I did have water table at 44, then I could use this whole soil profile. And then I'd say TD, total depth, and then I start to look at see if I see all the different horizons. I don't see really that many horizons. I don't see a lot of variability other than those that I've already seen. So I need to do the texture of the soil, and that's after I put it through a 2 millimeter sieve. I got to estimate the percent of rock.
This is texture, what was on the spoils pile after going through the 10 sieve. This is a texture example.
So there's Warren did texture a little bit of that material. And everybody's seen the sieve, right? Know what it looks like. So So there's the sieve.
What number's that?
This is called a 10 mesh, 2 millimeter. And that's roughly, what kind of a percent of an inch is it?
2 million.
Probably
Yeah, you know, it says, it doesn't say it in inches, unfortunately, it says it in millimeters. Oh, there you go. Maybe 0.08 inches. 0.08 inches.
800ths of an inch.
Okay? And remember Warren told you that the upper limit of gravel is 3 inches? That's the diameter of this beaker. That's pretty convenient. Gravel? No, bigger than gravel. So if it's retained on this screen, that's where we start out with gravel, fine gravel, all the way up to 3-inch material. Then we got cobbles and boulders, but we won't worry about that right now. Okay, so am I supposed to wrap this up right now? Okay. I don't know that I see all the colors I'd like to see for redoxamorphic features, okay? But I've got plenty of other indications. Probably down here I'm getting into some really gray colors, and my chroma has probably changed a little bit. And we're getting into more detail that I want to get into. We've already got our real good indications of water table conditions. This is a good indication of a water table. These roots are another good indication I've got a water table. So now let's go just walking through the profile and starting to log, as I said, texture, percent of rock fragments, matrix colors, the colors that we're seeing. Mostly I'm going to just say brown. It's brown. Don't get, we could use a Munsell color chart, but for this field exercise I'm just going to call it brown. Is everybody okay with brown? You want to go with a different color, purple? 15 shades of gray, whatever. That's what it is. Models, I don't see a lot of models in this. We're going through a quick profile. My next column would be to document the redoxamorphic features that I see. Then I'm going to do the structure shape. Do I see any structure shape? I don't see obvious structure shape here. And whether it's, and then the grade of that structure. So I'm not going to use a lot of structure here. There may be some here, and if I'm going to use that, if I do see some good structure, how does that help me? I can go with a little higher loading rate if I've got a moderate or strong structure in the soil. You can always err on the side of caution and say, I don't want to take advantage of it, so I'm just going to go with, I don't see a strong structure.